Hello and welcome. Today we're going to be talking about an interesting subject, which is the math sequences that we usually know, using a very nice concept in Microsoft Excel, new concept which are recursive lambdas. Recursivity is a concept that we usually use in programming. The idea basically is this: so you have a function, so you give it an input, you give it a condition to run out. If the condition is met, so the function will stop. If not, the function will be applied on itself, so will run over itself. So that's the recursive lambda. So you call a function inside itself. So with this thing, we're gonna solve what we call two famous and well-known sequences. The first one is the Fibonacci, the second one is the Collatz, which is very interesting. Okay, so let's start with the Fibonacci sequence. The Fibonacci. I'm gonna give you an idea about that. The Fibonacci is basically this and this, and you sum this with this, and you start going like that. So it's if we mathematically want to calculate that, so it's basically x minus 1. So if we want to calculate the Fibonacci of this number 2, so it's basically the x minus 1, which is 2 minus 1, plus 2 minus 2, which is 1 in this case. For the 3, we have x minus 1, which is 2, the Fibonacci of 2, and the Fibonacci of 2 is this. So 3, the Fibonacci of 3, sorry, is 2 plus 1, and so on and so forth. So the idea will be, as we're going to use this method to implement the Fibonacci sequence. So I'm going to call lambda. So lambda basically is an Excel function that lets you create your own function. So lambda, let's say x or inputs. X is my variable that I'm gonna write. It's my what we call parameter. It's my argument of that function. So x, we're gonna do the condition. So if x is less or equal to 1, then 1. So give me 1. So when we're gonna run out the function, and it will call itself. When x is equal 1, it will stop. It will give you 1, and it will go out of that loop, and it will stop calculating inside the function inside itself. So if x is less or equal than 1, so give me 1, else you're gonna give me let's say Fibonacci or fib, let's call it fib of x minus 1 plus fib, sorry, plus fib or x for x minus 2. Okay, we're gonna close that. And now the lambdas basically, so you create a lambda, it will give you a calc problem. So to avoid that and to really create, because it doesn't know that, so basically if we're gonna have another video talking about lambdas and how to debug them. For now, we're gonna use this lambda, and we're gonna go to sorry, let's leave this one. We're gonna go to the name manager, shortcut control F3. We're gonna do a new function. We're gonna call it fib. It's the same function we had in this. So we're gonna call itself. So we go okay. Let's say fib of 5. It will give me 8. Of 8, it will give me 34. Now let's try another thing to make it more visible and to try to create and generate this sequence. Let's try what we call the reduce function. The initial value, the reduce function basically is you give it an initial value, what we call a value, an accumulator, and you give it a value, so it will do the calculations. The last one will be the first one, so we'll do the next level calculation, and so on and so forth, and it will give you the final result. Now there is a pattern what we use vstack plus reduce to I'm gonna show you something. So reduce, let's say 0, because we can add 0 to a number, it doesn't affect it. The sequence of let's say 9 numbers or 10 numbers. Okay, now inside the sequence, the reduce function is a lambda helper function, so we need to use a lambda function, or what we call eta lambda. That's another subject, but a lambda. So the lambda here takes two arguments, x and y. Let's say accumulator. Let's give them a name, accumulator, and value val. So what we want is to do the fib, the function that we have created for val, and look what it will give me, 89. So it goes to the last sequence and it gave me 89. If I do vstack, look at this vstack, accumulator, and this vstack, look what it will give me. It's 0, 1, 2, 3, it's 5, because 2 plus 3, and 8, 5 plus 3, 13, 5 plus 8 is 13, and so on and so forth, and it will give me 90 and 89. Sorry, I said 98. So 89. The idea behind that is to do this face stack. This is a very magical pattern that not very known in Excel, but lots of experts use this pattern, the V stack plus the reduce function. So this is my I'm gonna insert some rows because it's taking more spaces. Okay, so this is my Fibonacci sequence. 1, and let's say v stack 1. I'm an 1. I don't know if it's correct. What's the spell problem? Oh no, Fibonacci 1. Okay, sorry, that's a little bit messy. 1, and let's say v stack of 0 and all this. Please give me the sequence. Okay, so this is the sequence. This is my Fibonacci sequence. So basically I'm gonna say give me I can now create a function based on this. So let's say lambda, and let's call it the variable x. So this lambda will take an x and it will return this sequence based on a null lambda, which is fib. The x now is 10 because I want a sequence of 10. Let's say x here, so it give me 10 values, and let's say this, so it give me a calc. If I open parentheses and say 5, it will give me the sequence. This is what we call debugging of the lambda. So 5 from sequence of 1 to 3 is 5, from 1 to 5 to 8 is we have 5 numbers. That what I have put here. If I say 9 or 8, it will start from, so I have done v stack of 0 plus 1, so these are 8 in count. So this is my Fibonacci sequence using recursive lambda. Now the Collatz function is beautiful because it's a very nice problem in math. So basically you start from a number and you start going down until you find 1. So this is basically the idea behind Collatz. It's like hitting a wall. So 16, the idea behind that is if that number is even, is we can divide it by 2. So we divide it by 2. If we cannot divide it by 2, if it's odd, so we multiply that number by 3 and we add 1. So the lambda will be lambda, and let's say x, and if and basically the final result should be 1. So if x is less or equal to 1, I want it to stop, so give me 1. Otherwise, give me, I'm gonna call my function Collatz, it's not defined yet, Collatz of if my x, sorry, is even, so it's, we can divide it by 2, is even, x divided by 2, so x divided by 2, else is 3 multiplied by x plus 1, and go for that. And let's do another beautiful thing, which is v-stack. We can go for x for now, and I can drop that. So this, let's add that function, and please work, please. Let's call that, because you should give it the same name that you have gave it in the lambda definition. Call that, and let's say this, and 5 place. Oh, this is so it's working now. Okay, so if I say Collatz of 80, so this is the idea. Now the idea behind this number, so if I go for, let's say 89, so I say if is even this, then divide this by 2, else 3 times this plus 1. So it's odd, so it will do 89 times 3 plus 1. This is even, it will divide it by 2, and so on and so forth. So the idea will be just like this until we find 1. Sorry, I have to continue until we find 1. We didn't find it yet. Well, so close. Yes, we find 1, and afterwards, look what's gonna happen afterwards. It's just gonna start looping inside. So 1 is odd, so 1 times 3 is 3 plus 1 is 4, and so on and so forth. It will be just like that. So we have to stop at the first one, which is this one. Okay, now to solve this problem, we can say now Collatz of 89, and it will give me the same result, and it will start from that. Now from this we can say how many, what is the I, what is the alpha, what is the limit that we needed just to find 1 from a certain number. I can go from 102, and it's maybe less, maybe more. If I go to 5, 5, so 5, 16, 5 times 3 is 15, plus 1 is 16, 16 divided by 2 is 8, 8 is even, so divide by 2 is 4, 4 is even, divide by 2 is 2, and 1. So we have the sub after each step after 5 steps. So this is the idea behind that. This is my Collatz function. Thank you everybody for watching. Thank you.